In the current Kubernetes cluster, two nodes are running, and Spire and NSM are deployed. The Meridio operator is also deployed in the namespace called red. I will now deploy one trench called trench A, two VIP addresses, one for IPv4 and one for IPv6, one attractor, two gateways, one for IPv4 and one for IPv6, one conduit called conduit A, one stream called stream A, and one flow called flow A. Once deployed, here are the Meridio managed resources we have in our Kubernetes cluster. Each pod has been configured based on the custom resources we just deployed. Secondary networks have also been created. Here between the LBFE pods and the gateway, so we have two of those links, and here between the LBFEs and the proxies, so we have four of those links. I will now deploy a new deployment containing an example target application container running multiple TCP and UDP servers together with the Tapa sidecar container. At startup, the example target application is configured to connect to stream A. Here is now how the system looks like. Since the example target application is configured to connect to the stream A, the targets have been created to the trench A and to the conduit A. We can see the connection between the targets and the proxies. Each target has received a new network interface. I will now connect to one of the targets to show the network interfaces for the conduit connectivity. So in this pod, we have three network interfaces. We have the loopback interface, we have ETH0, which is the network interface for the Kubernetes primary network, and we have NSM0, which is the new interface that has just been created for the conduit connectivity. Now everything is in place to send traffic. The flow A is configured to classify TCP traffic with 20001 as VIP address and 4000 as destination port into the stream A. We can see the traffic coming through from the gateway to the LB going via the traffic classifier and then forwarded to the stream A, which will load balance the traffic among the targets. The terminal on the top represents a gateway, which is also used as traffic generator. So we'll generate traffic from here using a testing program called mconnect that will run 400 short-term TCP connection with the targets and collect the hostname for each connection. I will run TCP dump in the target and show the traffic and show how many connections have reached the target. And now I will send traffic using mconnect. Now the traffic has been sent. We can see the 400 connection have been received by the 4 targets running in the cluster. We can also see the amount of TCP connection for received by each target, and we can see the targets that I'm connected to has received 102 connections as stated by mconnect. I will now deploy a new flow classifying UDP traffic with 20001 as VIP address and 4003 as destination port in a new stream called stream B. In order to send traffic, we also need a target to have the stream B opened. So I open it on the trench A, in the conduit A, and the stream is called stream B. Here is now how our system is configured. Stream B is now handled by NFULB. When we will send traffic, here is how it will look like. The traffic will reach only the target that have opened the stream B. I can now send UDP traffic with 20001 as VIP address and 4003 as destination port. First, I will run TCP dump as previously using the port 4003 and for the UDP traffic. And I send traffic using mconnect. So we can see the traffic have been received by only one target, the target that has the stream opened, and it has received 400 packets, as stated by TCP dump. And the traffic classified for the stream A can still be sent through the system as we did previously. And the 4 targets have received the traffic.